Next, my topic is Huffman coding. So in this Huffman coding, we are discussing about how to create Huffman tree and how to assign the binary code for the Huffman tree. So here in this we have to discuss about what is meant by Huffman coding, why we are using Huffman coding. So Huffman coding is a data compression technique. Huffman coding is a data compression technique in which the size of the data is reduced or the size of the message is reduced without any loss. So suppose if you want to store a file in your computer, a file of the size is big, then you have to perform the compression that file by using Huffman code. Then the amount of time required to store that file is less. So Huffman coding is used for data compression technique. Whenever you want to store one file in your computer, if the particular file is very big, by using Huffman code you have to compress that particular file without any loss of data. So that is called as the Huffman coding. Huffman coding, in the Huffman coding the data is inputted as sequence of characters. From that a table of frequency is created. So whenever you want to, data is inputted as a sequence of character. From that you have to create a table of frequency. For example, you have to take A, B, C. So these are the characters we are taking in the Huffman coding. From this sequence of characters, from that a table of frequency is created. For example, character, table of frequency. So here number of A's. Characters are A, B, C. So frequency, how can we calculate the frequency? Number of A's 3, number of B's 3 and C's 2. So this is the table of the frequency. So from the table of frequency, Huffman tree is constructed. From this table we have to construct the Huffman tree. Then encoding of each character is done. Encoding of each character is done from this frequency table. That encoding will be binary encoding. The encoding of each character is done. That encoding will be binary encoding. Now consider one example. We will discuss very clearly. Now you have to construct the Huffman tree from this table, or else we will take another example. First of all, we have to take the example, that is character frequency A, B, C, D, E, F 2, 3, 5, 7, 9, 13. So this is the table of the frequency. This is the one example we are taking now. So from this table we have to create the Huffman tree. For that, creating the Huffman tree, first step we have to follow step 1. That is, we have to arrange this table in increasing order of the frequency. Arrange this table increasing order of the frequency. This is the first step we have to follow. After that, step 2, that is we have to select two characters. From this we have to select less frequency characters. Select two characters which have less frequency. So we have to follow these two steps. The first step is arrange this table increasing order of the frequency, and step 2, select two characters which have less frequency. So now we have to start step 1. So already we are arranged all the characters increasing order of the frequency 2, 3, 5, 7, 9, 13. Now next step, select two characters which have the less frequency. So first of all we have to write A 2, next B 3, after that C 5, D 7, E 9 and F 13. So we will merge 2 and 3 to create the parent node. Here these two are the less frequency characters. So we have to merge 2, 3 and create the parent node, that is 5. So this is A and this is B. So this is the parent node. So these two are completed. Now from this 5 we have to select the two characters which have the less frequency. So what are the remaining? C 5, D 7, E 9, F 13. So these are the remaining characters we have. So now we have to select the remaining two less frequency characters. So less frequency characters are 5 and 5. Now we have to create the parent node 5 and 5, that is 10. This is A and this is B. This is C. So after that what are the remaining characters we have? D 7, E 9, F 13. Again we have to select the remaining characters which have the less frequency. So here we have 7, 10. Now it is completed. So here we have the remaining characters D 7, E 9, F 13 and also 10. So here we have to match D 7 and E 9. D7, E9 we have to merge now. So after that we have to create the parent node from D7 and E9. So what is the parent node? 16. 16 is the parent node. So after that what are the remaining less frequency characters we have? So here we have the trees 10, 5, 2, 3. This is one tree. After that we have 16, 7, 9. After that we have the character 13. Now we have to match 10, 5, 5, 2 and 3, 16, 7, 9 and also F13. What are the less frequency characters we have now? 10 and 13. So we have to match those things. 10, 13. What is the parent node here? 23. So 5, 5, 2, 3. What are the remaining characters we have? F13. Now we have to match remaining characters 23 and also 13. So what is the final tree? 23 and 13. 30. And also we have this tree also, right? So this tree will be added. $39, then we will get 16 here, after that 23, next 7, 9, then we have 10, 13, 5, 5, 2 and 3. So this is the final tree for the given Huffman coding frequency of characters. So this is the final Huffman coding tree. Huffman tree. This is the Huffman tree. So now we have to assign the binary code for the given tree. What is our final tree? 39, 16, 23, 7, 9, 10, 13, 5 and also 5, then 2, 3. Character with minimum frequency on left side and the maximum frequency on right side we are taking. So here we have to assign the binary code for the given tree. How can we assign the binary code for the given tree is 0. Now assign 0 and 1. So 0 is for left node, 1 is for right node, 1 is for right node. Now we have to assign the zeros and ones for the given tree. So this is obviously left, so we are assigning 0. This is obviously right, we are assigning 1. After that this is left node, that is left side 0 and this is right 1. So this is left 0, 1 and 0, 1, 0, 1. So now we have to find out the binary code for each and every character. So here 7 means it is D, 9 means E. So 2, 3, A, B. After that this is C. Then we have to 13, we have 13, that is F. So we have to find out the binary code for each and every character. For A, what is the binary code for A? Now see A. What is the path for A? 0, 0, 0, 1. So the binary code is 1, 0, 0. Next, for B, what is the path for B? So here B, 1, 0, 0, 1. So this is the binary code for B. After that for C, what is the binary code for C? Here we have to check the path for C, 1. Here we have 0 and 1. So 1, 0, 1. So after that for D, what is the path for D? Here it is D. What is the path? 0 and 0, 0, 0. After that E. What is the path for E? 1 and 0. Sorry, 0 and 1. So 0, 1. Next for F. So this is F, path 1 and then 1. 1 and 1. So these are the binary codes for the given characters. Now I want to create a table for the Huffman tree. So what is the table we have to create? So obviously we know character, frequency, then code. We already finding the binary code. Character, frequency, and then binary code. So this is the final table for the Huffman coding. So here we are taking characters A, B, C, D, E, F. What are the different frequencies for these characters? 2, 3, 5, 7, 9 and 13. What are the binary codes? Already we are finding the binary codes for each and every character. So we have to write 1, 0, 0. After that 1, 0, 0, 1, 1, 0, 1, 0, 0, then 0, 1 and 1, 1. So these are the codes for the respective characters. Two observations we are doing here. Every character having different code and length also different. So for this character the code is 1000, 1000, and for B 1001, for C 101, for D 00, for E 01 and for F 11. So this is the table Huffman coding. For this is the table for the given Huffman code. So this is also called as the variable length coding. So this is also called as the variable length coding. And it is also called as the lossless data compression technique. So this is about the Huffman coding.